Okay, in this example, we will do one where the PXF run multiple vehicles is used, but instead of building the vehicles every single time, we'll use saved vehicles. So just to kind of give an example of how this would be done, um, let's select a few vehicles. So if we do PXF library browser, list vehicles, and let's just take a collection of vehicles here. And what you can do is build these vehicles first and have a pre-built set of vehicles. And you can do that very easily here. By creating a vehicle list. Once that vehicle list is created, what we'll do is we'll loop through and build each individual vehicle. So we can demonstrate how to do that. Let's see here, close parentheses. And let's clear the screen, go back to the file. So now we have this list of vehicles. So what we'll do is we'll loop through the list of vehicles and we'll instantiate each vehicle using this PXF system class. Create initialize using the vehicle file. So we'll go through and create each one. And what we'll do is we'll create a directory. We'll call it Saved Vehicles. We'll cd to that directory. We'll call this a vehicle model library. Or we could call it vehicle diagram library because it's a library of Simulink diagrams. And let's call this call it Saved Diagrams. We're going to make that directory. We're going to cd to that directory. And then what we'll do is we'll go through and build in base workspace. So we'll build each diagram and save diagram to present working directory. And we'll just save it with the diagram name. We'll call this multiple vehicles. We'll call it run with multiple vehicles, and we'll just append saved diagrams. Okay, so now we'll save those diagrams. So we'll run this, and it will take each vehicle in the vehicle list and you'll go through and build each one, it'll cd to that directory, go through each vehicle in the list. It'll instantiate a PXF system class, which is the internal class that's used to modify, build, evaluate, even run in some cases the a vehicle file. It will build it in the base workspace, and then it'll save that diagram. So let's run this. So that should be running. And if I go to this directory here, you can see Amber Development Library Saved Diagrams, that it's building those vehicle models and then saving them out. So that's the first vehicle, the EIS belt integrator starter generator mid-size 6-speed vehicle. So it's created that one. Now it's creating the next one. It'll just iterate through that list and build each one. So we'll give it a few minutes to build, and then we'll come back and see how to add that library to the path and then run using that library of saved vehicles. Okay, you can see that each model has been built. So I'll close each of these diagrams. And now that each of these diagrams is closed, you can see that they're saved here in the libraries folder. What I'll do is I'll add this path to the project folder. If I go to development and I'm in this demo project, what I'll do is I'll edit the project file. I'll append it as a library here. Cut. I'll save it. And I'll call this Saved Diagrams. And then I'll rerun the A startup file to reset the paths, to add that folder onto the path. So if I go here, we could see that Saved Diagrams is now on the path. And then now that we pre-built those diagrams and they're on the path, what we can do is we can then do the run vehicle. So if we do run vehicles, and we could do run multiple vehicles, and we do create using defaults. So we create using the defaults. So if we instantiate that class, what we can do here is we do run vehicles, and we have to make sure that don't rebuild used cached pre-built models is set to true. So as long as that's set to true, it'll use the cache pre-built models. So then what we can do is we can go through and loop through the vehicle list. And we can create a single run. Multi-single run. And we'll create it using the vehicle and the vehicle list. So we'll create a single run. And then we'll also then attach the process. So we can attach a process. So we can do create it. I think it's add. It's add cycle or process, and we could add a cycle. So we could do a cycle, fuds1.aCycle. And so we set the vehicle, we set the cycle, and then we add that to the run vehicles. Add vehicle or run vehicle process. And we'll add the single run. So we'll add each one of those from the vehicle list. So let me uncomment the vehicle list. And then what we could do is we could do run vehicles.run. And then do the same thing where you get the results as table. And we do run vehicles.get result as vectable. So this way you can go through each vehicle in the vehicle list. We could do the run vehicle. We could also do things too where we do run vehicles and we could do number of parallel runs. We set that to something greater than 1, and then we could set the distributed computing. So distributed on is equal to true. And that will use the local profile. So what it'll do is it'll run the distributed computing with the local profile that's set. So what we'll do is save this, and I will click run. And I forgot the S here. There we go. I click run. And we could see that, oh, we had an error. Actually, I think it's because I didn't set the profile. So let me hold off on that for a second and just see if that runs. You can see it quickly opens the diagram and starts running. So hold on one second. Let me oops, now we'll run each one. So let me stop it. Okay, so let me go back, put those back in, and then I have to set the oops, distributed. Hold on, you have to find the local profile. So if I go to, let me look at the examples. If I go to development, program, examples, batch runs, and I look at, let's see, run distributed cycle. And let's just open one of those files up. Is it in here? Distributed on, oh, cluster definition. I believe that's probably what's missing here. If we go to cluster definition and then use the local profile for the cluster definition. So this ADIS file has different options to say, okay, use the local profile and then save, use or load vehicles from a certain location, save vehicles to a certain location. It has a lot of those options that you'd use when using the parallel computing toolbox in terms of where your files are and where you want to save your results. But in this case, we just want to run locally, so I'll just run that. And it will take a few moments because it will build the diagrams and run each simulation and then return a table as a result. So we'll give it a few minutes to run. Okay, so the simulations ran, and now we could look at the results table. And we could see, we printed out, we could see each vehicle that was simulated and then the results for it. So that's a quick way to run simulations. And without having to rebuild the diagram every single time. So that could save, 30 to 40 seconds on each simulation run if it's not rebuilding the diagram. There are some internal optimizations that are done on PXF run multiple vehicles, so it doesn't necessarily build it on every single run, but it is still better not to have to build the diagrams at all on these simulation runs. So this way you could just pre-build everything, have that set of vehicle diagrams ready, save it as a library, and then run simulations just by setting that one parameter and run those simulations with the vehicle diagram. This don't rebuild, use cache pre-build model. And that ends this demo.